Oh my god. Hello, guys. Hello. Hello, everyone. How are you doing today? How are you doing today? Oh my god. How are you doing today? Digimon World Lo-Fi. Hi, guys. Welcome. Welcome to some shit that we're doing. I should change the name of my stream. Oh, okay. Hold on, let me move this over here. Remix. Hold on, what was the name of my last one? Study. Yeah, we're gonna call it that. Study, teach, C#. Oh my god. That's weird. Can I change like dang, I put it in the gaming category, but I can't. All right, homies. Unfortunately, today I also ate some ice cream, so it might get a little rowdy up in here. I might have to run away. It is what it is. What's up, Javen? Javen Williams. It's unfortunate that I decided to eat ice cream twice. I don't know what I was thinking, but I know my stomach is bubbling. Anyway, why don't we learn some C#? So I decided that I'm gonna make a course. Gonna make a course on C#. So, ooh, okay. I don't know if you can hear the music, but it sounds good. The music is sounding good. I feel like learning C# is easier if you're doing Unity type stuff, right? So, A, 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 A. Okay. Can you hear the music? The music is good. It's funny because I have this playlist on my Apple Music. I didn't know they even have stuff like this on Apple Music. All right, let me post this. Let me post this stream somewhere. Give it to this dude. Yeah, buddy. Yeah, buddy. Yeah, buddy. It's some yeah, buddy type things. Oh, I think I got kicked out of a server. I think I got kicked out of a server. Oh, did I? No, I didn't. Oh, self promo. Here we go. Shit, it's crazy. They destroyed this entire server. For what? For what? Why, dude? Why did you do it? Why would you do it?
That's an hour? Hell no.
Oh my god, dude. So totally radical. Alright, we're gonna make a new project. We're gonna call this project C Sharpness _course. Do I have to connect? See, now there was something that happened here. Oh, okay. All right, let's get it started. Let's get it started. Okay. I should rename this stream to, I'm gonna rename it to, this is gonna be day one. Where can I, okay, I'm gonna come over here and change it. Dun-dun-dun-dun, dun-dun-dun-dun-dun, dun-dun-dun-dun, dun-dun-dun-dun-dun. Comments, content. One. Bam. All right, let's get it started. Let's get it started. Let's get it started. Hello, my amazing, adoring fans. All of you are here today, and I'm glad that you are here today. Being here is one of the best things you could have ever done with your time. Like, let's be honest. Where else are you gonna be? Today, we start learning how to program, right? And learning how to program is one of the best things we could do. Let me turn the... All right. Okay. I'm here. All right, so I'm gonna teach you guys we're gonna learn how to program in Unity. I think this is one of the best ways to learn C# because you can actually see things happening and shit. So I should stop cussing to make this really official. So the first thing we're gonna do, make sure you download Unity. Make sure you have all the stuff. Make sure you have an IDE like Visual Studios, or I think it's called JetBeans IntelliJ or whatever. Whatever it is that you choose to use. I don't care if you choose to use Notepad, whatever. I don't even know if you can use Notepad like that. But the first thing we're gonna do today is we're gonna create a folder. We're gonna call this I'm just gonna call this part 1, and then we're gonna create another C# folder called variables. Okay, and I'm gonna teach you guys about variables in C#. So let's create a script, C# script called variables. Press enter. It's gonna open up your IDE of choice. Mine is Visual Studio 2022. All up in this biatch. Hopefully it opens. If it doesn't open, I'm gonna be sad. I'm gonna be real sad. Okay, it didn't open. Are you gonna open now? Okay, there we go. You gotta click it twice. Gotta warm it up a little bit. All right. So the first thing we're gonna learn today is variables. So there's different types of variables. I'm gonna run through this. There's different types of variables in C#. You got your ints, you got your strings, you got your floats, you got your bools, and there's a host of other ones, but we're gonna focus on these right now. Now, there's a few ways, there's a structure to creating a variable, and you have to think of a variable like you think of a box. Okay, so variables are boxes where we place information, and so we need to tell C#, we need to tell Unity, we need to tell whatever it is that we're trying to make a variable. So this is the structure of making a variable. We do we can do int, like say for example, we want to make an int, and we want to call that int age, right? So we're gonna say int age equal 33. There's also, and that automatically I think makes it private, but you can also make it public. And we're gonna get into that later. But just know that if it's public, that means other scripts, other classes can access it. And if it's private, nothing can access it but this specific class. All right. So, well, first, let's say, okay, so an int is gonna be a whole number, like the number 3, or 27, or 3000. Strings are going to be characters, like your name. Like my name is Chris. My channel name is Polyhype. And we can put another name like Bacon. All right, okay. A string is any assortment of characters. Okay, it's just like a word. Okay, you gotta think of strings as words. Floats are numbers with decimals in it. So 3.14, 2.75, and 600.367, something like that. Okay. And bools are one of two things. It's gonna be true or false. Okay, true or false. True or false. Either it's going to be true or it's going to be false. And that's going to come into play once we go into logic. Okay, So let's get on this. So we know let's create a variable. Let's say we have int age. Int age. So there we've there's a difference between initializing and declaring. I'm not even gonna go up into that. There's a difference between saying int age and then int age equals 3, right? So you put what type of variable you want. You put the name of the variable. You put the type of, or you can call it a data type. The type is int. The name of the variable is age, and we have set it to equal 3, right? This is how you do it. So for example, we can do string name equals what? Let's say polyheight. Polyheight. And that's a string. You always put the characters in between quotation marks. Let's say we have a float. And let's call that float pi. And we all know what pi is. Pi is 3.14. Now, you see, you can't just put 3.14. When you create floats, you have to put an F at the end of the number. And now it's correct. See that? See, if I erase the F, it gives me an error. Literal of type double cannot implicitly convert it to type float. Use an F suffix to create a literal of this type. So I have to put an F at the end. All right, and then we have bool. So we're gonna have bool. Did you lie? And we're gonna say true. True. This person did lie. So now we have our variables. We have our variables. So now, since you know how to create variables, why don't you create your own variables? Create an int, create a string, create a float. Do all the things. Create all of those things. Oh, this music is getting kind of oh, this is Greyloy's Mansion. What the hell is this? It's getting kind of spooky. Final Fantasy Lo-Fi? Okay. All right. Okay. Now, since we got that, now, why don't you create your string, your float, your bool. Now, the next thing we need to do is to learn how to print something to the console, the log. So in Unity, typically, in C#, you're gonna do console.writeLine and but we're not using, we're using Unity. So we're gonna do debug.log, and then you can put anything here. You could put like bacon. We could put sausage. By the way, I copied this line by pressing Control D. And we could put eggs, right? And if I save this and I press play, it usually prints to the console, but you see nothing happen because in Unity, it has to be attached to a game object for this to even like show in the console for it to do anything. And in order for something to attach to an object, it has to be a mono behavior. It has a inherent from mono behavior. So what I'm gonna do is I'm gonna create a 3D object. Let's call it a cube. We're gonna call the cube variable. And then there's a few ways I can do this, but right now I'm just gonna drag my script to it. Oh, that didn't work. Hold on. Oh, that's because we're in the wrong scene. See, this is the game view, and this is the scene. You want to be working in the scene view. Want to drag this to the scene view, right? Drag it to the scene view. And now that we have a script attached to the object, when I press play, you'll see that right here, it says bacon, sausage, and eggs. And it's exactly what we type right here. Bacon, sausage, and eggs, right? Okay, now let's do something different. Let's say we can also replace these strings with the variables that we made. So let's put age, name, pie, and we're gonna put did you lie. We're gonna save that by pressing Control S. We're gonna go back into Unity. And then we're going to, clear this, and we're gonna press play. And as you can see, it wrote 3, age is 3. It wrote polyheight. We gave the variable, the string name, the polyheight as its value. 3.14, that's pi. And when we say, did you lie? We set that to true, and it says true right here. And so you can do a lot of things with variables. We can also add variables together. Let's say we want, let's create a variable. First, let's stop this from running. Let's say, for example, we're gonna say int current year equals, we're gonna say int current year, and then we're gonna say int birth year, right? Now let's say if we want to find out how old this person is. Well, in the start method, by the way, these are methods. The update method is called every frame. Okay, so if you're running 60 frames per second, it's going to be called 60 frames per second, I believe. I could be wrong, but it's supposed to do it every second or every frame. The start method, it will run once at the beginning. As soon as this starts running, it'll run once. So we don't want to put a variable here and it's just constantly saying, okay, current year equals 5. We don't need that. We just need to set it once. So in start, I'm going to say current year equals 2023. All right? Okay. Then I'm going to say birth year equals, let's say 2001, right? The birth year is 2001. But we want to find out how old this person is. Now watch this. Let's create another variable. We're going to call this int age. Well, actually, let's do something different. Let's say we're going to create it in here. We're going to say int age equals current year minus birth year. Ooh, I wonder what'll happen. And then we can go debug.log. We can go debug.log age. So we took current year, we set it to 2023. We took birth year, we set it to 2001. We could have also did this, and that would have still been correct. And we're going to debug.log the age. So let's see what the age is going to be. We're going to press play. And it says right here, the age is 22. The age is 22. Yes. That person is 22. If you were born in 2001, you are 22 years old. So let's spice this up a bit. We can do something called string concatenation. That's just a fancy way of saying we're adding strings together. So for example, we could say you are space age years old, right? So you are plus age plus years old. So this is going to say you are space, then we're going to put age, which is going to be current year minus birth year, plus space years old. Okay, so we concatenated these strings. We put a variable right here. Let's see what this comes out to be. Let's go to play. It says right here, you are 22 years old. Now I want to show you guys something else. And I'm gonna have to let's see. There's something called string interpolation, and I'm gonna bring it up right here. String interpolation. That's just a fancy way of saying, like, okay, so I'm just gonna read it. It's gonna be boring, but whatever. The money character identifies a string literal as an interpolated string. An interpolated string is a string literal that might contain interpolation expressions. When an interpolated string is resolved to a result string, items with the interpolation expressions are replaced by the string representations of the expression results. That's a fancy way of saying, let's see, let's try something. Let's say we want to write, let's put this right here, and let's put this right there. Can I just exit this? Okay, cool. So let's say what I want to do is with string interpolation, I could say debug.log. Let's see, debug.log. Then we use a money sign. We use a money sign, and we say you are curly braces. Hold on. Do that again. So remember, we put this money sign right here. Money sign. You are age years old. You see how that works? So string interpolation, you can put the variable or another expression inside of these curly braces. You put a money sign at the beginning. It knows that it's going to do string interpolation. So instead of doing all those pluses and stuff, and you know, like we did it just before, we could just say you are age years old, and let's see what happens. Go here, press play. It says you are 22 years old. So we did it right. It says the same thing. It's the same thing as what we wrote before. So let me write it out again. So this and this are the same exact thing. So I'm just gonna save this, press play, and you're gonna see it writes the same thing. You are 22 years old. You are 22 years old. It's the same thing, except this is with string interpolation, and that allows you to. It makes writing like strings easier. So, say for instance, we were playing a video game, right? And we said int damage equals 20, right? And let's say we have string monster equals troll, and we have string player equals Chris, right? We got string player equals Chris. Now we'll say something like we're gonna say Monster did damage to player, right? Monster did damage to player. So you can already guess what this is going to come out to be. Monster troll did damage 20 to player Chris. Control S. Press play. Troll did 20 to Chris. We can go back in here and write damage. Save that. Go back into Unity. Let's close Unity Hub. Press play. Troll did 20 damage to Chris. Nice. Troll did 20 damage to Chris. We good. We did the thing. We did the thing. All right. So now since we got that together, we know how to add things together. Let's move on. It's gonna be. I'm thinking about making a course out of this, but right now I'm just gonna like skip through some things. Just gonna, So now we're gonna go into logic. Logic is extremely important, and that's where our bools come in. So we're gonna say if parentheses if true debug.log this is true. Okay, now watch. If this condition is true, then what's in these curly braces will run. What's in this block of code will run. So as long as this is true, this will happen. So let's see what happens when we run this. Attached to Unity. What? Is it? Oh, never mind. That's weird. Anyway. Press play. Go on the console. It said this is true. This is true. It ran because what's in this expression comes out to true, because I mean it's basically true, right? So let's say if let's put something false. Let's say if 1 plus 1 is greater than 50, debug.log this is true. So is 1 plus 1 greater than 50? Let's see. If it prints, then it is. And nothing printed. So it's not true. It's not. It's just not. It never was. It never is. It never will be. Now, we can add something extra to this logic. We can say else. So if this is true, then we do this. But if this isn't true, then we do this. So we're going to say debug.log it's not greater than 50. So again, if this is true, then this will run. If this is false, then it'll go to the else and it'll run this. So let's see what happens. It's not greater than 50. Oh my God, it is not greater than 50 because this was not true. So this didn't run. So we ran this. There's also something called the else if. The else if. So we can write another expression right here. We can say if 1 plus 1 is less than 50, debug dot log debug dot log. Two is less than 50. Two is more than 50. Don't forget to put a semicolon. And then we're gonna go into Unity, press play. And you see which one evaluated to true. It says 2 is less than 50. So this one came out to be true, and this one came out to be false. Okay, so that's logic. If, else, if. Okay. Let's go into, let's see. If so we did if and we did else, if, and else. All right. So why don't we do so that's conditional logic. Now what if we do while, do while, and then we're gonna go into for. All right. So while is similar to if. So we're gonna say while this is true, this will happen. So while true, this will happen, and this could run forever if we, because let's say if true, we want to say debug dot log. Hey, if we run this, because this is always true, it's always gonna log hey. It's always gonna log hey all the time. It's not gonna stop. It's not gonna stop logging hey. So let's say, let's do something that we would, let's say while age is less than, oop, we messed up. Let's create a variable called age. Let's enter, let's say int age equals 5, right? Int age equals 5. And let's say int drinking age equals 21. And so we're going to write every time while age is less than drinking age, we're gonna debug log hey, you can't drink yet. Get out of here. Okay, so the age of this person is, let's do something, let's do like 15. So the age of this person is 15, the drinking age is 21. So while age is less than the drinking age, of course you can't drink, right? It's just not gonna happen. So what we want to do is, if we run this while this is true, it'll continue to run and run and run and run and run. So something that a lot of people do is add an incrementer. So we're going to increment the age. We're going to say age plus plus. So every time this runs, it's going to add 1 to age. Now, age plus plus is the same as saying age equals age plus 1, right? So if this is 15, this would evaluate to 16, and this would evaluate to 16 as well. So they're both the same. And when this is 16, it'll come back and evaluate to 17, then 18, then 19, and so on and so forth. Right? So now let's see what happens. Let's see what happens. Let's see. Let's add string interpolations. Say, hey, your age, you can't drink yet. Okay. So now let's go back into Unity and let's see what happens. Press play. And it says, hey, you're 15, you can't drink yet. You can't drink yet. Get out of here. Hey, you're 16, you can't drink yet. Hey, you're 17. Hey, you're 18. Hey, you're 19. Hey, you're 20, you can't drink yet. But when it gets to 21, it doesn't even print that, right? It doesn't even print that. Because this is while age is less than drinking age. Once age is 21, it's not less than drinking age. So it's not going to print out. But what we can do is say we can add a conditional. We can add an if statement. We can say if age equals 21. Now, mind you, this equal sign is not like this equal sign. This equal sign, one equal sign, assigns this value to this variable. This is a comparison. It's saying if age is equal to 21, not age is equal to 21. You get what I'm saying? So if age is equal to 21, then we're gonna debug. Oops. We're gonna debug.log. You can drink. You can drink. You can drink to your heart's content. You can drink as much as you want. Hold on one second, y'all. Doop, 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 doop. Oh, hold on, guys. Put that right there. Put that right there. Let people know. All right. Okay. Back on it. All right. So now here's the next step. We're gonna go in here. We're gonna press play. So it says you're 15, you can't drink. You're 16, you can't drink. You're 17, 18, 19. You're 20, you can't drink. And then it says you can drink. That's because it's age. We're checking up here. We say age equals 15, drinking age equals 21. While age is less than drinking age, we're going to debug.log. Hey, your age, you can't drink yet. Get out of here. And then we're going to increment age. So age is 15. It comes through here. It gets evaluated. Age is actually less than drinking age, so it's not. It is true. So then we run this block of code. We say debug.log. Hey, you're blank. You can't drink yet, right? And then we increment the age. And then right here we say if age is equal to 21, then we're going to debug.log. You can drink. If this isn't true, then we keep going and going and going and going until age is 21. And see, that's what happens right here. 15, 16, 17, 18, 19, 20. And we can actually come over here and insert age. Let's say your age. You can drink. Save that. Run this in Unity. Right? You're 15. You can't drink yet. You're 16, you can't drink it. You're 17, you can't drink it. You're 18, you can't drink it. You're 19, you can't drink it. You're 20, you can't drink it. And then it says you're 21, you can drink. So that's the power of loops. Now let's look at another loop. Let's look at the do while loop. So the do while is a little bit different. The while loop is going to check if the condition is true or not before it runs it. Do is just going to run it, period. It's going to run it one time before it even checks if it's true or false. So we're going to say do debug. We're going to say debug.log we're gonna say 1 plus 1. We're gonna say 1 plus plus, and then we're gonna debug dot log. No, oops. We're gonna say age plus plus, and then we're gonna debug dot log age. Right? Debug dot log age. Okay. Debug.log age, and it's going to say while do this while age is less than drinking age. So we're going to do this block of code. We're going to do let's do this first. Let's debug.log age first. So we're going to log age. We're going to write age to the console, and then we're going to increment it by 1. This is like saying age plus 1. This writes to the console, right? So it's going to go here, run this block of code one time regardless of if this is true or not. Then it's going to say, okay, well, while age is less than drinking age, then we're going to run again. So the gate, we're going to call this a gate. The gate is at the end, but in a while loop, the gate is at the front, right? So we're going to do this by running this block of code. Then we're going to check if this is true, and if it is true, we're going to run it again and run it again and run it again until it is not true. So it can run forever, but eventually it should not be true because we're incrementing age each time. Okay, so let's see what happens. Okay, so right here it prints 16, 17, 18, 19, 20, 21, right? And if you notice, we got to 21 and then it stopped. If we did when we did the while loop, it didn't even print 21. And that's because the gate is at the end. So age plus plus equals, if it was 19, then it goes to 20. It checks, is 20 less than the drinking age? It is. So then it goes back up here. It debug.logs the age 20, and then it increments at 21, and then it checks if age is, and then and then it checks. So this is getting confusing, but it's okay. I'm going to do it one more time because it's kind of weird. Okay, so it's going to do this. So let's say age is 19. So it debugs.logs 19 to the console, comes over here, adds 1 to it, then it becomes 20. Comes over here, goes over there, now it's 20. Prints that, now it's 21. While age is less than drinking age, comes back over here, do this, do that, and bam. So it's gonna do it until it isn't true. It's just like a while loop. People rarely use do while because I mean, I don't know what's the, I don't know. Why would you, there's while loops and then there's this magical one, my favorite one, for. And this is a little bit complicated. So the way the for loop works, let's say, so the for loop is divided into a few parts. First, you have your variable. We're just gonna say you have your variable. You have your variable. Then you have your expression. Then you have your incrementer, right? You have your incrementer. Okay. So right here we have int I equals 0. While I is less than length, I plus plus. Let's trade length for drinking age. Let's say, let's put, I think we can do that, and then we can do this. Then we can do this, age plus plus. But let's do something like this. Let's say int age equals 15. So int age equals 15. Then we're gonna say age, while age is less than the drinking age, we're gonna plus plus. So a for loop condenses all of that logic that we put in the while loop. In the while loop, you had to initialize a variable here. You had to do the incrementer right here. It was, it wasn't in one package, but with the for loop, it's in one package. So we initialize the variable. We say int age equals 15. Then we check this condition if it's true. Age, while age is less than drinking age, then we're going to increment it. So this is how that works. We're going to say, debug.log, use string interpolation, and we're going to say age, right? Age, debug.log age. Then we're going to put an if statement right here. We're going to say if age is greater than or equal to 21, we're going to debug.log you can drink, right? All right, let's see if that works. Probably will, probably won't. Let's see. Okay, age 15, age 16, age 17, age 18, age 19, age 20. But you see, it didn't even print this part out. And it didn't print this part out because once it got to 20, right? It got to 20. We debug.log the age, and then it incremented. And so once it was 21, it didn't even the for loop stopped. It didn't even continue. So what we can do is say while age is less than or equal to, no, we're gonna say greater than, less than or equal to drinking age. And we're gonna say once age equals 21, debug.log you can drink. So now if we go over here and we press play, it prints out you can drink. So it goes from 15, prints out 15, checks if this is true. It's not true, it comes back, turns to 16, 17, 18, 19, 20, 21. So it's 21. It's like it debugs.log 21, and then it checks this. So yeah, that's a for loop. Then there's something magical called the for each loop, but we're going to get into that a little bit later for each. So the next thing we're going to learn are arrays. And arrays are something I have to refresh on. But let's say we had an array. We had a certain amount of ages, right? Let's say we had three kids, and each kid had a different age. Let's say the first kid is 12, the other kid is 16, and the other kid is 17, right? So 12, 16, and 17 kids age. So we have 12, 16, and 17. So the way we create, and these are ints, right? They don't have a decimal, so they're ints. So let's create an array of ints. So the way we would do that is, and let's bring up the documentation really fast. No. Oops. Okay. So I think it's really important that everybody start getting into like going into the documentation and finding examples. There's a few different ways you can write arrays. There's a few different ways you can create them, and if you read the documentation, it'll all become easier, right? So right here, it says, hold on, what is an implicitly typed array? Interesting. Okay. So let's read through this. You can store multiple variables of the same type in an array. Multiple variables of the same type. Multiple variables of the same type. If you want the array to store elements of any type, you can specify object as its type. Now, that's another subject we can get into, but everything is an object. This is object oriented. Everything is an object, but we're not going to get into that. In the unified type system of C#, all types, predefined and user-defined, reference types and value types inherit directly or indirectly from object. That's a whole nother can of worms. So here's the format. We write in the type, and then we write in the array name. So we could say int brackets ages, bam, and we created an array. Okay, the number of dimensions are set when an array variable is declared. The length of each dimension is established when the array instance is created. These values can't be changed during the lifetime of the instance. Blah, 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 blah. So there's a few ways you can create an array. So we could say, let's go right here. Let's say we can say int ages. So we have to say int bracket ages equals new int, and we have 3 ages. We can put 3 right here, right? So there you go. Or what we could have done, this is interesting because there's multiple ways you could do this. Let's see. Ooh, this gets very complicated very fast. Okay, we're just gonna do it the regular way. So we could say int ages. We're gonna say int with the brackets to show that it is an array. We're gonna name the array ages, and then we're gonna say equals new int, and inside the brackets 3. And this is gonna be the length of the array, right? It's gonna be a length of 3. And what that's going to look like is, here's the thing. In arrays, you start counting from 0. So while it does have 3 elements, the elements are 0, 1, and 2. But the length of the array is 3. Don't ask me why they did it like that. We just start counting from 0 in programming. It is what it is. Just take it how it is. Take it how it is. All right. Okay. Int ages equals new int 3. Okay. So let's say we want to place values because right now it is just 3 empty elements inside of this array. There's no, the elements aren't set to anything. So what we can do is we can say ages, and we pick the index, ages 0 equals, let's say 12. Ages 1 equals 16. Ages 2 equals 17. So now this is the last thing we're gonna do today, and I'm gonna do it pretty fast because then I'm gonna continue on to the next thing tomorrow. Let's say if we wanted to print everything inside of this array. Okay. For each int age in ages, debug.log kid is years old. Let's see what happens when we run that. Hope I turned it off. I didn't turn it off. Look at that. Just having stuff run. The kid is 12 years old, kid is 16 years old, kid is 17 years old. So the way the for each loop works is that it iterates over a collection, and there's different types of collections. An array is a certain type of collection. It is a collection of a certain data type. It can be a collection of objects. It can be a collection of ints, a collection of whatever class that you choose, whatever object that you choose. But they all are going to be of the same type. So we could literally create, let me see, I think this works. Objects equal new object, we're gonna say 3. And in this we could put everything that is of type object, but we're not gonna do that. So the way the for each works is that it'll say int age, right? So this is what we're gonna call the variable each time it goes through. It's gonna say int age in ages equals int age in ages. Ages is our collection. Age is us going through each index in that collection, right? And so kid is age, it is 12, it is 16, it is 17. And that's all we're going to do for today. Now what I'm going to do is play video games because I'm tired. I'm tired of talking. Let's see. Where's my music? Where's my music, man? That's great. Hold up. Oh. What is this? Oh, nah. Where's the original? What? Where's the original Dragon Quest monsters? Let's see what I have in my Steam library. Let me change the name of my stream. What the hell? There's all these cool features on the interwebs now. Alright, let's see. It's crazy that I can't find this game. don't think I've ever played Dragon Warrior Monsters. What is Dragon Warrior Monsters about?
Sometimes if I forget to buy a yeah, this is actually one, so that's good. Pretty sure.
Stopping notes. No. So now we've got Stupid Hood Squid. So he's not out of here before he does something dangerous. So I hope that.
Hell, our home. Frozen when heaven extinguished the pyre.
Alright, let's see. Okay. Um You know, I want to try something different. I want to try something a little different. Yeah, we're gonna go with this. Yeah, let's go with that. Damn. Yeah, this one is better. When you summon your first imp unit each turn, gain 1 and draw 1. Spikes deal +1 damage per stack. Okay, now. Eric Benet just subscribed. What's up, Eric Benet? I don't know who that is, but what's up, mommy? What's good, homie? So we gonna do this. I think I know who that is. I am playing something called Monster Train. I'm playing Monster Train. It's my chill game that I've been addicted to as of late. I really enjoy it. I just play it and chill. No. Deal 3 damage. Deal 1 damage. And then do that. Alright. We'll deal 1 damage to that thing. 3 damage, deal 10 damage. Might as well do that. Because it comes with do that. Get +1. Do that. Do that. Do that. Damn. He's done. He's dead. He gone. He gone. Dang. This is a really good card. But let's go with Sweep. I like that card. Yeah, I think that's it. I think that's it. Ooh. I don't have anything that's healing right now. That's the thing. That's a big problem. Oh, goody. Goody, 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 goody. Uh-oh. Uh-oh, Spaghetti-O. So we're gonna deal 10 damage to that thing. We gonna do that, eh? We gonna do that, man. We gonna do that. Do one of these. 25. Okay. Ooh. Kill that. Kill that. That's already gone. That's gone. He gone. He did. Put that right there. Hold up. 31. How did he get 31? Quick, sweep. Triggers after dealing a killing blow. Oh shit, that's crazy. I didn't realize that. Alright. Yeah, this is my new guilty pleasure and shit. Like, I like playing this thing and just chilling. I don't know why. I just like it. We're gonna do Sting, we're gonna do that. 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 Alright. Alright. Apply 3 rage, do Sting on them, and then let's see. Done. Oh, by the way, this game is called Monster Train. I don't know if I said that to you. Yeah, I'm gonna do that. Oh man, which way should I go? Which way should I go? Let's go this way. Double stack. Oh, that's crazy. Dang, that sucks that it has consume on it. Whatever, fuck it. I'm not that good at this game, but I like it. Plus 20 and consume. Deal 25 damage twice. Yeah, let's go with that. Fuck it. What? Oh shit. Oh shit. Huh. This is hard. I don't know. This one right here. That's the best option. IMO. In my opinion. I won't be able to put her on the same. Yeah, I won't be able to put her on the same thing. Oh, does he get? Yeah, he has quick. Oh, cool. there. Oh shit. Deal 23 damage. Alright. This is looking good. Oh, I should never did that. Alright. Because every time it kills something, it gets more... it gets more attack power. Guess I'm gonna sting. That. That's it. I think that's it. I think that'll do it. Yeah. Done. Done. Five plus 10 and spikes 3. I think that's cool. What is that? Rage on friendly units adds an additional +3 per stack. Alright. Let's go with that. Oh shit. Which way do I don't have no money. Should I go that way? I can get rid of 2 cards and then I can duplicate something. Let's get rid of this and this, and then let's duplicate this, and then skip that. Multi-strike 1, quick multi-strike 1, enchant. Quick. No, that. Let's go quick sweep. Quick sweep. Alright, let's see. Hopefully I pull her the first turn, and I did. Magnificent. Put this over here, put this over here. Put it right here. Alright. Alright. just put that right here. I should have used this one, but no. I mean, all right, that's it. That's all I'm gonna do. It. Oh shit! I could have put. I'm just. Shit, I could have put that right there. I'm gonna just leave that alone. Then. Put this right here. No. Dang, it really is gonna fuck up some shit. So that spikes, that's 4 times 3, that's 12. Fuck, I messed up. Yeah, I messed up. I messed it. Alright. That's all I can do. And hope for the best. Alright. Sting. I mean, put this right here, and let's hopefully it goes right. Alright. Oh shit, Ember Drain. Ember Drain? Oh shit. Oh shit. I mean, that doesn't really matter. This will though. Been doing that. Alright. 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 Whatever. I didn't want to take that much damage, but it is what it is. Conserve, collect. That's actually a good one. Clan pack. Draw +3 next turn. Restore 1 health. Gain 1. Draw +1. Let's go with that. That's actually pretty good. Let's go with that. Let's go with 8. I feel like this is gonna be bullshit. At the start of the turn, add a random imp unit to your hand. When you play a spell spells in hand that costs. Alright, dudes. Okay. +10 and spikes. Bam. Bam. That's crazy. Alright. I should never upgraded that one like that, but it is what it is. Let's see.